Hello everyone, in this video we will be discussing Kjeldahl method, that is to calculate the percentage of nitrogen present in the organic compound. So I'm sure you will be able to solve the numericals easily after watching this video. So what you do is you take organic compound which is containing nitrogen and you mix with concentrated sulfuric acid in a Kjeldahl flask. This is a Kjeldahl flask. It's a long neck flask with a round bottom, and when you're heating these two, that is compound containing nitrogen and concentrated sulfuric acid in this Kjeldahl flask, the two will react. You're heating it with the burner. So we turn on the burner and we are heating it. So the nitrogen inorganic compound, it reacts with sulfuric acid and it will result in the formation of ammonium sulfate. So in a way, we have removed nitrogen from the organic compound and converted it into ammonium sulfate. So ammonium sulfate will now be there in this Kjeldahl flask. Right, this is step 1. This is your step 1. You can complete the estimation in 3 steps. The first step is this. And in this step, what is the principle in it? The principle in this is to remove the nitrogen of the organic compound as ammonium sulfate. Right? So this is the first step completed. Now let's move on to the second step. In the second step, what we obtained in the previous step, that is ammonium sulfate, this is step 2. Right? So what we obtained, that is ammonium sulfate, which we are now referring to as Kjeldahl liquid, we take in this flask. There is a flask here in which we are taking the Kjeldahl liquid, which in a way is ammonium sulfate. And from the top we are adding NaOH to it. When we add NaOH to Kjeldahl liquid, that is ammonium sulfate, what will happen? You can just write that equation. It is ammonium sulfate. You are mixing with NaOH. So the two will react and just exchange is happening. You will have sodium sulfate and this is ammonia and OH, which will result in the formation of ammonia and water. So that means ammonia gas will be liberated from it. Kjeldahl liquid, when it is mixed with NaOH and heated, then ammonia will be liberated. So from the nitrogen compound, first we remove that nitrogen in the form of ammonium sulfate. Now from ammonium sulfate we have removed nitrogen in the form of ammonia, NH3. So that ammonia gas which is released from here is made to go into the another flask which is containing known volume of the standard dilute sulfuric acid. Standard dilute sulfuric acid means whose concentration is known. Whose concentration is known to us. Any solution whose concentration is known is called as the standard. It's standard sulfuric acid we have taken. And known volume, of course we know how much volume we have taken. We know the volume of it. We know the concentration of the dilute sulfuric acid. So ammonia from here is made to go in this. That means from here ammonia will again react with sulfuric acid and now it will form ammonium sulfate next time. Right? So that means ammonia which was released from here is now reacting with the known volume of the standard sulfuric acid and it results in the formation of ammonium sulfate. Now again in this you will have ammonium sulfate plus you will have little quantity of sulfuric acid which is left unreacted, because whatever quantity we have taken will not be consumed directly, will not be consumed completely. So whatever we have taken here, the known volume, out of that some quantity would have reacted with this and would have formed ammonium sulfate. So what you have in this, you have ammonium sulfate plus you have the unused sulfuric acid. Got it till here? Okay. Now we move on to the step 3. The step 3 says the sulfuric acid which is unused here. We cannot separate it, but of course there will be ammonium sulfate plus sulfuric acid also, no? So that sulfuric acid, we don't know how much of sulfuric acid is left behind now. We know the total volume of ammonium sulfate and the unused sulfuric acid. The total initial volume of sulfuric acid we know. So out of the total initial volume of sulfuric acid, how much has reacted? That we have to calculate. Right. So to calculate the reacted one, we will be finding how much is left over. So that sulfuric acid is now titrated with NaOH, which is a standard solution. That is a third step where titration is carried out with a standard solution of NaOH whose normality is known, whose volume is also known, the standard flask, that is with the burette reading we can make out. And in this we know the molarity, the normality, we know the here also N2, normality of NaOH we know, volume of NaOH we can calculate, how much we are using it. In fact, not the burette reading, we can calculate it by how much you are taking. Right. So with this normality which we have already taken, the standard sulfuric acid, that N2, N1 and V1 can be solved. This V1 we don't know. So this V1 will be for the unused sulfuric acid. Right. So we will use this and calculate the volume of the unused sulfuric acid. What is the product here? It is forming here Na2SO4 plus H2O. Right? So this was the third thing where we calculate the volume of the unused sulfuric acid. Using that unused, we can calculate the volume of the used. So how can we calculate that? Let me write here. So we can write volume of used sulfuric acid is equal to the total volume of sulfuric acid which we used it in the beginning, that means in this step, minus what V1 we have calculated from this titration. So we will be able to calculate the volume of the used sulfuric acid. Okay, so from this used sulfuric acid, we will be calculating the percentage of nitrogen. Now you must be wondering, this does not contain nitrogen. What are we aiming for? It is like how much quantity of the sulfuric acid has reacted, used in a way, the same quantity of ammonia would have been formed also. Because ammonia in this case, in this flask which we had taken, whatever ammonia was formed has reacted with some sulfuric acid. So equivalent of ammonia reacted and the equivalent of sulfuric acid used would be same. So we are calculating from sulfuric acid how much of ammonia is formed. Okay, I hope this point is clear. From organic compound, nitrogen reacted with sulfuric and formed ammonium sulfate. Now after ammonium sulfate is formed, that ammonium sulfate was treated with NaOH and then ammonia was formed. Now that ammonia has reacted with sulfuric acid, the used sulfuric acid equivalent will be equal to the ammonia formed. So with that we are going to calculate the percentage of nitrogen. How do we go ahead? I'll tell you. Now to understand that, let's see this. You have some flask. Suppose you have some flask in which you have taken ammonia solution. You have taken 1 normal ammonia and 1 liter quantity you have taken. So if 1 normal 1 liter ammonia solution is there, what will be the weight of ammonia in it? We can calculate by using normality formula. Normality is given weight by gram equivalent weight into 1 by volume in liters. What is the normality? 1. Weight we don't know. Gram equivalent of ammonia is 17. Nitrogen 14, 14 plus 3 into 1 by 1 liter. So we are getting the weight as 17 grams. So how much of ammonia? So we can say 17 grams of ammonia is there in 1 normal 1 liter ammonia solution. Okay, now this 17 gram of ammonia will contain how much of nitrogen? 14 gram. 14 gram of nitrogen. Okay, now from here we will go ahead. So what we can say is that for preparing 1 normal 1 liter solution, that is 1000 ml, I can say 1 liter with 1000 ml, 1 normal 1000 ml solution of ammonia, what is the weight of nitrogen? 14 grams. 14 gram of nitrogen, we can say 1 normal 1000 ml ammonia solution contains. It contains 14 grams of nitrogen. Therefore, if some normality N1 and volume V1 is there of ammonia, then how much nitrogen amount will be there in it? We can calculate 14 into N1 V1 divided by 1 into 1000. Right? This much grams of nitrogen it will contain. Okay, so now we can calculate with this gram of nitrogen what will be the percentage of nitrogen. So what is the formula for that? The percentage of nitrogen is equal to weight of nitrogen divided by weight of organic compound into 100. Okay, so what is the formula? I'll be writing here only so that it's there in one place. Okay, so we can write down here the percentage of nitrogen will be equal to, what was the weight of nitrogen we got? This one, 14 into N1 V1 divided by, this is 1000 only, 1000 into the weight of organic compound. You will have weight of organic compound into 100. So in this we can cancel out this 100, 2 zeros. So it is only 10 left over. So if you solve, it is 1.4 into N1 into V1 divided by weight of organic compound. Okay, this is clear. No more 100, because that 100 we have already cancelled out, this 1000 and 100. So only 10 was left over. So this is the final formula. Now you must be wondering here, this N1 V1 is what? N1 V1 we are using as the normality and volume of ammonia. But since the normality, the equivalent of ammonia and the equivalent of sulfuric acid were the same, so what we will use is this N1 and V1 will be the normality and the volume of sulfuric acid, because the equivalent is same. So what is the final formula, children? It is 1.4 multiplied by normality of sulfuric acid. Okay, multiplied by volume of used sulfuric acid. Used H2SO4. How much was there? How much is unreacted we calculated, and the used we did. Divided by the weight of organic compound. This is your final formula. Just see this. 1.4 into normality of sulfuric acid into volume of used sulfuric acid divided by weight of organic compound. So please note down the formula if you are not able to follow the whole step, because in numericals we will not be requiring the whole thing. We will be using just the formula. Okay, so now I will solve one numerical also so that you can understand the concept properly. Here is the question. This much gram, 0.35 grams of organic compound is Kjeldahlized and ammonia obtained is passed through 100 cc of N by 5. That means this is the weight of organic compound given. This is the total volume of sulfuric acid with this much normality of sulfuric acid is given. And it requires this much volume and the normality of NaOH. That is also given to us. And for neutralization, you are asked to calculate the percentage. Right? So the first step, children, would be that N1 V1 is equal to N2 V2. Okay. Now what is this N1 V1? Let this be for NaOH, and this one be for sulfuric acid. Then we will go ahead. What is the normality of NaOH given? It's given as 1 by 10. So it's 1 by 10 into what is the volume given? 154 is equal to how much of the normality of sulfuric acid is given as 1 by 5 multiplied by the volume. Okay, this volume we don't know. This volume this was the total volume given. Don't make mistake of taking this volume directly. This was taken, but out of which how much has reacted, we will solve it. So this V2 you will solve. When you solve this, V2 comes out to be 77 centimeter cube. Okay, so 77 is leftover. So leftover is this much, because the unreacted one we are calculating. So what will be the volume of H2SO4 used then? It would be the total volume 100 minus 77, that is 23 centimeter cube is used. Now using this we will be calculating now. Okay, what is the percentage, children? What was the formula? We will calculate it here so that it's clear. So we will be calculating the percentage of nitrogen is equal to, what was the formula we had? I'll just show you. You had this formula, children. Okay, so what was the formula? You have this formula, 1.4 you have into the normality of sulfuric acid, that is given as 1 by 5 multiplied by volume of used sulfuric acid, that is just now we calculated, it is 23, divided by the weight of organic compound, that is given as 0.35. So when you solve it, you will get it as 18.4%. This is your final answer for the nitrogen. Did you follow this question, children? Okay. So please practice the numericals based on Kjeldahl method. Okay. In the upcoming videos, we will also discuss the other methods to calculate the percentage of nitrogen, Dumas method, and even other elements. Thank you for watching.